Hello everyone, let's look at today's Leetcode problem. 3337 total characters in string after transformation to. Before starting this problem, let us look at the motivational code for today. Do not watch the clock, do what it does, keep going. So whenever there is a hard problem or anything that we feel we cannot go further, just take small steps and keep going forward and try finding solution even if it is a small piece of idea. Just break down large problem into small pieces of steps. So always keep going step by step. Okay, so let us understand the problem statement. So you are given a string S consisting of lowercase English letters and integer t representing the number of transformations. To perform and an array nums of 26 in one transformation, every character S is replaced accordingly to the following rules. Replace S of I to the next character, consecutive characters, next consecutive characters based on the nums array. So example, if S of I is equals to A and nums of, we are considering A as 0 value, and if nums of 0 is equals to 3, then A will transform into B, C, D. The transformation wraps around the alphabet. If it exceeds Z, let's say if S of Y, which is equals to Y, and nums of 24 is equals to 3, Y transforms itself into ZAB. Okay. So return the length of the string after tree transformation. Since the answer may be very large, return it modulo of 10 power 9 plus 7. Let us look at the examples to understand it a bit more detail. So here so all of the characters are, let's consider this A, B, C, D. So let's say each of these indexes A, B, C, D, and these will be Y and Z. So these will have 1, 2, 3. So we can count this way. So this will be 25 and this will be the 24. So now after t plus 2 transformation, so we have A. So let's say at t is equals to 0 or the initial value, we have S is equals to A, B, C, Y, Y. So at t is equals to 1, so we might need to convert A to T, B to C, C to T, and Z and Z. Once we reach the last character or the Z index, which is 25, then at t is equals to 2, we change B to C, C to D, and D to E, while Z changes to A, B, and so now if you see here, there are two additional characters, so the length would be result would be 7, and that's the answer that we need to return. So here in case of nums, it is given all of the characters would change to the next two consecutive characters. So in case of every character, there would be two new characters added. So let's say at A, Z, P, K, so we would be getting P, C, A, B, and C, D. K will take up L letter, and it would be 8. So there are few constraints that we need to keep track of. So nums length is always, nums array will be of length 26 indexes, and nums of I is equals to 26. So So this means, so every possible value in nums of I will always be less than 25. So 1 to 25. Okay, so let's look at a thought process on how we can solve this problem. So we can immediately think about a brute force approach where in a brute force approach, firstly we calculate string length. Firstly, we can think of a loop where we need to iterate t times, and next we would be having to keep track of a frequency which is for with respect to nums of I. So we will loop 0 to 25, and we will check if there is a frequency or of a specific character, uh, let's say a current character. Then we check nums of I with respect to this value, and if there is a nums of I which is, let's say we get a value here, and we might need to add and increase the frequency value. So new frequency with respect to these additional set of values. And once we have the new frequency, after each uh, change, we assign the frequency origin back to the new frequency. So just to repeat what we had, so let's say we have t iterations, so we will set a for loop t0 1 to t times, and once we will also keep track of the frequency of each character. So we will have a original frequency, let's call this original, and this will contain 0 to 26 25 with respect to s input string characters. So once we do that, so we will check if we will do 26 times 0 to 25 times for each character, and if we check, and let's say this is I, and if frequency of I exists, that is original frequency, then we further check the nums array, check the nums array, nums of I, nums of I, which would be the same. So let's say if there is a character A and we find it in frequency 0, the similar change, a similar consecutive, the consecutive characters or the new frequency that needs to be updated will be present in the nums array as discussed, and we might need to keep track of new frequency, which is frequency original at I plus the next set of characters. Uh, let's call this J loop, and so every time we update this new frequency, and after this for loop, once after this for loop is completed, after this for loop we assign the frequency original with the new frequency. after this for loop, we assign frequency original with the new frequency, and this would be spread operation. As we can see, even though this is a simple approach, but this gives a time limit exceeded because we are having to go about uh, t into, so this is expected, so we would be doing it t to the power n, n being the length of the string. So here we have the length of the string, which may be sorry, not the length of the string. So we would be looping nums nums of I times. So this is the replacement or the new characters that we should be replacing it. So this will be time limit exceeding because if we see the constraint, so t can take up values such as 10 power 9. So if it is 10 power 9 and if we are multiplying with, let's say, 26, so this will obviously exceed, and that's the reason that we see time limit exceeded. Let's see a better approach. Let us see if we can have a better approach. So we know that, let's say, we have a frequency array of 0 to 26 with respect to initial character, initial input character is initial input string is, and we can have a nums array which can be tracked as 0 to 26, 25 representing A, B, C, dot, 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 Y and C, and here we can have the number of times a new character or the occurrence needs to be C. So let me just separate these two. So let's say, let me just take an example. So here, let's say the nums is all 1. So only thing is S is of value A, B, C, Y, Y. So we have first iteration where all of these, or the initial value where all of these values will be, we can say 1 and 1, and these two values, which is Y and Y, will have a count frequency of 2. This is at the 24 position where it would be 2. And once we, this is, let's say, at the initial stage, and once we have t is equals to 2, we change this to A, B, just understand the intuition behind what is happening, and then we will see if we can really convert this to a useful solution. So on transformation of this index, so we will check uh, the new set of characters that should be added based on the nums array, and we know that it should be traverse to the next character only uh, with if it is of value 1. So we move the value which was here initially 1, so we make this 1, and we mark all of these values 0. Once we here which was 1 previously, we move that to 0, and similarly we are also going to change it this way, so where this would be 0, while we have uh, z which gets converted to 1 and 0, and all of these values also 0. This is at t transition 1, and now at t transition 2, or the final transition that we are looking for. So the value b which gets converted to c, which would be 1, and similarly 0, 0, this would be d on the second transition, d, and d c will become e, which is this one, and so this could be at z, which would, if we look, if we uh, replace this value with nums of z, so we get 2, so we might need to replace this with next set of characters, so we increase, so there were 2 set of y's which was here, so this should be 2, and initially this should be 2, so this gets transferred to 2 here, so this would be 2, and the 2 gets converted to 2 here, 2 characters. Since this should, the nums of z is equals to 2, so we might need to take up the next set of 2 characters, and this will become 0, which was initially 2, this gets converted to these 2 values. So if we next, if let's say this as a matrix B which is of size 26 into 26, and we have an initial frequency which is of 26 into 1. So let's say we multiply these two matrices, maybe B into I, where this is 26 into 26, and we have a 26, sorry, 1 into 26. So let me rewrite it. This is row and this is column. So the result after multiplication, let's say result would be uh, 20. So rule for multiplication that we need to know here is uh, matrix 1 column should be equal to matrix 2 row, and resulting matrix will have matrix 1 row into matrix 1 column. So this would be 1 into 26 with this value and this value. So let's say if we, since let's assume this as a stage where, and if you see here, we are having to multiply t times. So we are having to multiply a B matrix t times, or we are having to multiply B t number of times. So t is multiplied, if t is equals to 2, then we are multiplying 2 times. Similarly, this would become uh, b square times. So let's say this is 26 into 26. This would be 26 into 26. B square will be 26 into 26. So another optimization that we can have is matrix exponentiation, where matrix exponentiation would be useful in such recursion, or in cases where we have certain expected situations where we let's say Fibonacci numbers where we have n minus 1 plus n minus 2, and we can apply matrix exponentiation here to optimize the time, optimize the time complexity to possibly log of n, or better of t of n. So in our case also we can do something like this. So this is matrix exponentiation, where in simple terms you can say, let's say we have a multiplication factor of 12. So we can divide this by 2, and division of 2 would give us 5 into uh, 5 into 5, and n power 5. So, and similarly, n power 5 can be taken as n power, let's say 2, which is 2 into 2, and we can consider n power 2 n power 1. So multiplying all these, and once we do all these, we can add up the remaining value, which would be this one. So we can only do 3 operations instead of having to multiply 11 times. So that's an optimization which would reduce to O of log of n. Or in case of odd, in case of even, let's say if in the exponent value is even, then this would be of O of n times, as we know m to the power even value divided by 2 will become m even by 2 into m even by 2. Yeah, let's see if we can implement this to a solution, and let's go to our Leetcode. Okay, so firstly let me just start declaring few constant variables such as mod, which can take up a big n. So we have few key functions that we need to define. So one is matrix multiplication. So here I'm creating a resulting array with 26 rows and values being filled with 0, and matching this type with begin to have further multiplications of the same type. And here we shall be multiplying the two arrays. We need to check if the specific element is 0, and we simply continue to the next iteration. So we multiply with the matrix multiplication where with respect to column k and the value of the second one, next we create a simple function where we calculate power of the matrix. If we are translating p times and we would like to apply matrix explanation. So exponentiation. Exponentiation. So yeah, sorry. So it's exponentiation, right? So we would be having to multiply matrix with the power, and we can optimize this multiplication with matrix exponentiation. Okay, so here similarly we would be having some result similar to the one that we saw here. So we would be creating such a way, and we would be having to for the power is on, then we multiply. And once the power gets even, so we can simply have a and just know that this is an identity matrix where all the 26 rows and columns are filled with 1. Right? This is for a power of 1, so we would be multiplying it just for once, and all the other values would be exponentially reduced. So that's the idea that we have. Once we do this, we can simply return the result. Okay, so we got two functions. One is matrix exponentiation, where we want to multiply a matrix a number of times or t times for the given problem. Now let's continue. So let's do the main things where we firstly create a transition array with so we are looking for each character in the nonce array which denotes the consecutive characters that come about. So we are having to iterate 0 to 26 times, and we are checking the value in the nonce array based on the character index. Right? So with the character index count, we add up the values of the next set of characters that come. We modified 26 just to keep it within the boundary of the alphabets, which is A to Z, and we also mark the transition the transition array, so we might need to multiply it the key times. So we do that with mat.js matrix, and once we do that, we calculate or we multiply, we check the count of the initial string which we have, and we do that by so now we multiply the two arrays, which is the matrix array that we have here and the count array that we have here. So that would give us a resulting array where we can take the final sum of the occurrence of characters from. And we do the same for the matrix multiplication too. And this would be 1 cross 26 matrix, as we are multiplying two matrices, which is the count matrix and the matrix power matrix, which is 26 by 26, and this is of 1 cross 26, one row and 26 columns. So the resulting array that we have here would be of one row and 26 columns, and that's the output that we would be counting the resulting frequency. all of the output or the result will be big int format because we are having to do so many multiplication operations, and as we see the constraint with 10 format, so we have kept all of the values with the value of big int. Let's see if we can submit the solution. Okay, so this should be nice. We should iterate many times. That makes sense. Let's see if we can resubmit. We should be higher than March. This is an identity message, and we are just going to print. Okay, so here is not the format. We find number 53. So we are almost here. Okay. We can just keep it as a change, right? I think this should work this time. Alright. So please like and subscribe if you